My name is Peter Detender. I'm a Microsoft technical trainer from Redmond, Washington. I've been a trainer for a bit more than 14 years, but within the Microsoft role a little bit over 5 years now. The trainings that I typically deliver are Azure architecting, developing, together with DevOps, and now moving more to AI and Copilot. In session 5, we'll talk about using the aspects of prompt flow. After you learn the components, it's really important to show you what it looks like and how to use it. This will be an extensive demo to show you how it works and get everything up and running in our prompt flows. In the end, your prompt flow will be the nerve center of your custom Copilot. Let's get started. So we're moving on in the scope of the training, and eventually if you think back about the title, it's Developing Custom Copilots, where now for this section here, it's all about using one of the so many capabilities, but maybe one of the more, I would say, crucial ones in your developing cycle out of AI Studio, and that's using prompt flow. Now, what we're doing with prompt flow is really following what I actually explained in the previous section. We're going to build an input, we're going to define the nodes, and in the end, we want output. Now, one of the main characteristics, I would say, one of the functionalities that we typically see being used out of prompt flow is that RAG concept. Now, we talked about RAG in the previous sections, and it was a little bit positioning what it was all about. So I'm going to spend a little bit of time here and explaining actually on the whiteboard a little bit more how the vector component is one of the crucial pieces here. Now, in short, again, if you think about RAG architecture or RAG functionality in a custom Copilot AI solution, it's about defining custom data that you're going to bring in. You're going to rely on the large language model together with obviously the NLP, natural language processing capabilities to recognize context. So in this example here, I have two different documents where it's about kids and playing and having a fun, happy time. Where it's two different data sets or one data set with two different documents as the content. And what we're trying to do is now retrieving information. So it could be a prompt like, I have, 5, 7-year-old kids. I want to take them to the park and anything else. Or literally using that phrase, why not? The children play joyfully in the park. So that's the context. Could be part of a story, could be part of summarizing text, or maybe describing vacation time or anything like that. We're now out of that retrieval concept. That's where the data comes in. So we relied on the large language model to recognize the context. You could say almost translating it to recognizing the keywords. So again, it's about children having a good time in some location, in this case, a park. Now, technically, and it's a little bit more binary speak if you want, like ones and zeros, the main thing is like, how does this large language model actually recognize that context? And even more so in RAG, where is that augmentation coming in? Now, the technology behind it, or the concept behind it, is vector-based indexing. You deploy Azure AI Search, you connect it to a data set or a data backend, and you're going to store information in a vector-based scenario. And again, I'll use the whiteboard later on to show you a bit in a graphical scenario what a vector actually looks like and how it's been based up. Now, looking at this slide here, we had the document on one side, and it's recognizing the keywords, and it's mapping them. So we do have a correlation, if you want, what we describe as semantic similarities across different keywords. And that's how our RAG architecture is now searching for results. It's trying to recognize the keywords, and it's going to try and find correlations. So the correlation here is children in document 1 and kids in document 2, where it's slightly the same context. We still have kids, they're still happy, but now they're running around on a playground. So it's kids, that's fine. There's a lot of similarity between kids and children as the keyword. There's a lot of similarities between happily and joyful. It's like a sentiment, a feeling, you could say. And that's where, if you look at that diagram, all those keywords are closerly positioned to each other. The playground and the park are about the same. It's an area where you can have a good time, where mainly I would say kids are having a good time. Joyfully, happily is moving back to that sentiment, and that's how that vector recognition of keywords is actually being based up. So with that, let's jump into the prompt flow that we positioned before, but I owed you the demo on that. And you can obviously figure out that our prompt flow will be a little bit more complex than just input nodes and output, because we're going to integrate a bit of that RAG solutioning as well. So in this next demo, it's all about using prompt flow. I positioned the concept. I didn't really have a demo at that time. So now I think it's more than enough time to start really building our prompt flow. And I would say, as mentioned in the presentation, it's really going to become that heart, the nerve center of building your custom copilots. So obviously, we're still in our Azure AI Studio. We have the same demo hub. We have the project. And now we're going to move on underneath here, the tools section. We have prompt flow. Now, the idea with prompt flow is that we're going to build some sort of an automated flow. We're going to tweak it a little bit, what our chat conversation, our custom copilot solution should look like. So we're going to start from scratch. And initially, maybe before doing that, let me open up the chat playground and checking once more if everything is working. I know I showed this before, but it's always good to go back every now and then. Maybe you deployed some new models, maybe you did the fine-tuning, what we just covered, and you want to make sure that everything is still running as it should be. So I didn't tweak my system message yet. I'm just asking like, hey, scenario or platform AI capability, what can you do? And it's again providing that same rather generic message. Now from here we can adapt it a little bit. I'm going to inject a little bit of a larger system message, but it's partly the same context as before, where we have our travel assistant. Now, zooming in a little bit more, I'll make it a little bit bigger. We talked about system message in previous sections, and I talked about how to customize it, how to fine-tune it a little bit. But I didn't expose everything, because otherwise I wouldn't have enough data to fill up this demo, right? So one of the really cool things you can do in the definition of the system message is, for example, something like this. So you define an objective, and I'm using the asterisks in between, but that's just highlighting. It's not really required to do that, because in the end, it's just text information. But the large language model understands like objective means this is what you want me to do. So we're going to allow the system to help with assisting users or customers, right, with travel-related inquiries, offering tips, advice, and recommendations. Next to that, we define a section here called capabilities. What we're doing here is telling the AI assistant, this is what you can do. Based on the prompt, it's going to respond like, oh, I'm allowed to do this, or I do have the skill set, the knowledge, I have the experience to help you with that. And then finally, we're providing a section with instructions where now we're telling like step number 1, you need to engage with the user or with the customer. In step number 2, we want you to use available resources. You're going to tailor the response. You're going to make sure that recommendations are practical, and then eventually using some follow-up questions. So it's a bit more, I would say, an advanced option in the system message, but in short, it's still the same message than what we used before. And again, remember, you need to apply the changes, and then typically giving it about a minute. And then you can ask the same prompt, what can you do? We're now, instead of providing that generic answer, like I'm an AI assistant, what it did before, it's now nicely coming back with what we told that AI engine to become. So I can assist with travel-related inquiries, which means it's literally coming from here in our system message. So that's pretty good for now. So we lock down our environment, but now we're really moving into turning it into a solution, you could say. So I'm going to move over to prompt flow. I could actually do this from here on the side, or if I go back in my exact same chat conversation, I can start prompt flow as well. Now, for some reason, it's refreshing that I did not expect, so I need to repeat this. But then at least you know from going through these demos that Everything is live. It's not pre-recorded and nicely cleaned up. And we're going to do what can you do? And we're back in the travel-related inquiries. Cool. So from here, I can now do prompt flow. The difference between using prompt flow from the tools on the side or prompt flow is obviously that I'm already in this specific chat context. You can provide it a name. So it's asking some descriptive name. I would call it the travel chat flow. And this is going to create I would call it a simple chat flow setup. Now, I wouldn't call it simple in the way that it's like limited in capabilities, but it's really up to you as the AI solution developer, the custom copilot developer, to really start tweaking it, tuning it, making it more advanced, making it more complete. I would say making it as advanced as you want your copilot to become. Now, if you think back about the presentation, we have the baseline of what a flow should be about. So we have the input section, we have the chat, and we have output. Now, in this case, the chat is there. Why? Because I started with, hey, can you please configure me a prompt flow starting from the chat playground. If I'm doing this from the tools prompt flow option, it's not really going to have that angle in there. Next to that, we need to start our compute session. So what we're doing here is really using Azure Compute to make this environment available to be used. This typically takes a couple of minutes. So there's a little warning here where it tells me it's going to take like 1 to 3 minutes. I'm not really going to wait for it for now, but I'm going to use that time to walk you through the interface a little bit and explaining what's actually happening. Now we start the flow with input. So we have the section input here, and it's actually reflecting the configuration blade here in the middle. Next to that, we have our output, and that's reflecting the output window here. Now, out of the baseline template, you can see that the input is expecting the chat history. Why? Because by design, I would say we go for chat completion, which means, like in all the previous examples I shared, it's going to know the context, what we were talking about. Like in one of the previous demos, I think one of the first ones where we used the playground, right? It's where I asked a question about like London and then adding like, what can I do here? Where out of the chat completion history, it remembers like, oh, the here keyword actually points to London as the location you want to visit. We can add additional large language models. Now, for now, since again, I started from the playground, it already has context from that GPT 3.5 model in our case. I can add additional prompts. I can add Python code as well. So that's where I would say you really thinking about what is the purpose, what are the capabilities, what are the characteristics of my custom copilot that I want to build for my users, for my customers. That's really what you're going to start thinking about here. And then you can add additional tools, but for now, I'm not going to make it more complex than it should be. Now, if I move on from here, we had input, we had output, and eventually we have the chat option, the chat configuration options. Now, the nice thing is that it already picked up the system message. So this was literally the system message that I provided to my chat playground like a couple of minutes ago, and it's reusing it. Because again, I launched prompt flow from that playground, and it's reusing as much components, as much information as it can reuse. Now from here, we need to define a few settings because now it's just the definition, the configuration, where the next step is really building that integration like, hey, my dear prompt flow, I want you to interact with a connection, where the connection stands for using an Azure AI service. So up here, the first setting in the chat conversation box is which connection do you want to use. I'm still in my Demo Hub environment, which means I'm going to use the Demo Hub as a connection. It's a pointer to the AI service. The API I'm going to use is chat. And remember, you can also use chat and chat completion. So the interaction, the capability might be slightly different. If you want to use that option, then it's up to you to go for that. We define a deployment name, so that's where we point to the deployed model, our large language model, and we also define the response format. So I'm using type text, which means that although in the backend of the AI service, the chat conversations input-output will always be stored in a JSON file, it doesn't really, I would say, represent nice in your testing window in the chat playground if it would show you the raw JSON format. But in a full application mindset, if you're using this in Java, in Node, in C# or Python, it might be beneficial to actually have that JSON object in full. But for now, my demo testing, I think, is good enough from here. I'm going to save my settings, something that every now and then I forget about. And as you can see, it's adding some additional context into our configuration/coding window. So it's going to add some parameters for item in chat history. So basically, when there is input coming in, we're going to use it as input, and then we provide the user message, the assistant, and then we go back to the user. So really helping to build up that chat modality. We saved it. So for now, I think the next step is testing it out so you don't have to go back to the playground, because that one only recognizes a deployed model, where now we want to have the chat conversation specifically based on the flow that we just created. Remember, our context in the system message is still a travel assistant. So I could come up with roughly the same prompt as before, where I'm going to go like, well, I have one day in London, and can you help me pointing out what I can do there? Now, the idea is from here that it's not a one-time shot. You can, again, go back to the system message. You can modify some of the parameters. You can add some changes into it. And eventually, it's producing some output. So again, our little copilot here is a travel assistant, allowing us to help our customers, the travelers, providing some touristic information, where now my context is London. So everything looks okay. I think my chat is working fine. And from here, I'm going to run a deployment. Now, what we're doing with a deployment is now translating our prompt flow into an actual pre-built, pre-configured, boxed copilot environment. So we're going to create a new endpoint. We can modify all the names, but I like to keep my demo hub as some sort of a reference. Identifying a virtual machine, because that's where we're going to use the Azure compute in the background. By design here, it mentions instance count 1. 3 is the default, but I'm going to use 1. I don't need high availability for my virtual machines because it's only a demo environment, but in a full production environment, depending, by the way, on the amount of users, depending on the complexity of the flow, that's where you might need to make some changes in the number of instances. I think that's pretty much it. So I'm going to close by running the creation. So once I saved my prompt flow and we triggered the deployment after testing it, you get a couple of notifications in your Azure AI Studio where you can see that the endpoint for this prompt flow got created. It's still working on the actual in progress step, and then also here running another part of that deployment. Now, since it's going to show up as a new deployment, I can actually close this for here. And when I move down to deployments, you can see that we had our traditional GPT-3.5, GPT-4 that we deployed all the way at the start of our sessions. And now it's down here creating a new one. So it's literally creating a dedicated new endpoint, and underneath it's now creating that deployment, which again in the end would become another little model on its own, where from here you're going to select it, and then obviously once my deployment is complete, I can go back to the playground. You can already figure out what we can do there as a test, running the chat, running the completion. It's now still nice going to act as our AI assistant, but specifically within the boundaries of the prompt flow. Now in that demo, I told you we are eventually moving to a more complex scenario, but it's hard to start with something complex if you don't understand the basics. So up till now, the demo was mainly input nodes with everything around it. We have the large language model integration, we have the connections, we have our output defined, and if you want, integrating the Python scripts, but I didn't really show that yet. Now, it's not 100% solid RAG-inspired architecture, and that's really where now we're going to bring in that Azure AI search, where we're going to build an index, and we're going to bring in our own data. Now, there's a whole bunch of steps here on the slide, and I'll again show you in an upcoming demo, but expanding a bit on what the data flow looks like, we start with, first of all, importing the data. If you remember from the previous sections, I talked about using Azure storage accounts, maybe using data lake, or using any other data set that you can integrate. It could be uploading files, it could be reusing another database like a Cosmos database or any other cloud-based database architecture. Where you have your product information, I uploaded my travel brochure scenario where I got PDF documents, uploading them, and now they are ready for our AI engine, our custom copilot, to reuse that information. So we start with adding our own data. Next to that, we upload the data, we provide the data, and what we need is that index. The indexing in our Azure AI context is possible thanks to Azure AI Search. Out of the search engine, which in the end was nothing specific to AI Studio, it's just a component that we bring in. Remember, the first lesson that we talked about was what is AI Studio and where do all these components fit? And that's again the beauty of that tooling, that platform, that management interface, that all the steps that you need to go through here as a developer, but also as a data scientist, are nicely coming together. Once you have your indexing up and running, you're going to reference to it using the context. Out of the flow, we start with a prompt. Can you provide me information about topic XYZ? Thanks to the RAG architecture or the concept, we're going to tell, like, hey, large language model, can you please formulate me an answer, what we called output, and it can only be based on information coming from that data set. And then last, the output once more is natural language processing, communication into our flow, and producing output. And then left and right, we have a few additional steps. That's where out of the node concept that I talked about before, you can bring in variations. You can add additional Python scripts. I want you to retrieve some data, use that data as input for my node action being a Python script, waiting for the output, and then using that output with maybe some sort of a if then else condition like the two arrows here in the pre-last step, and then eventually providing the final output. So we're going to go back to our demo scenario where I'm going to show you not just how to create a prompt flow, because that's what we already did, but integrating prompt flow with actual custom owned data, and then also touching a little bit on content filters. Close to the fine-tuning that we talked about in a previous section, but now integrating that concept in prompt flow. So now I think it's about time to show you how to optimize your prompt flow with yet another little capability. We already used the boundaries of the system message. We used our fine-tuning. We're now in the prompt flow scenario. I'm going to move on and talking about how to upload your own data sets and integrating your own custom data, actually forcing or blocking, depending how you want to look at it, your large language model to still use all its core capabilities, responding to prompts in a good way, acting with natural language processing, but instead of using information it compiles from the public internet, out of the fact that it's based on, trained on that information, it's now coming from your own data sets. So I'm going to go back to my hub, and we already configured multiple hubs over all the different demos that I had, but let me go back to my live demo hub. And for now, I'm going to jump into my already configured project from earlier demos, and we go back into our deployments. I'm going to use a new model. I've done quite some demos with GPT 3.5, GPT 4, where now I'm going to use text embedding. So there is version 2, you could use version 3. I'm going to use version 2 for now. Identical as one of the first demos in part 1, it's providing a description of the model, and it's also telling you like, well, this large language model is mainly built for helping you with embeddings. So we're not using it for chat completion, we're not using it like DALL-E for generating images, we're not using it like some of the Llama examples. Remember here, it's just using a deployment name, and just to make sure I'm not maxing out the capabilities of my demo subscriptions, I'm going to move down the number of tokens because, again, in my demo setup, I don't really need them. My deployment is there, my large language model is recognized, and again, just to highlight that nothing blocks you from only using one single large language model in your scenario. Let's add another one where I'm going to use the good old GPT-3.5. Think of this as combining multiple large language models in one single custom copilot solution. Now, talking a little bit about the custom data that I want to integrate, I'm going to show you what the data is about. So I have my travel scenario. We're still doing the same travel assistance, and I got PDF documents with information from cities. So I'm going to open up one little document here, and it's providing a name for our travel company. So my company, the travel agent, is Margie's Travel, and we have a flyer for our customers about New York, like information about the city, a couple of images, and some of the top hotels that you could imagine we have a partnership with. That's the data set we're going to use in our scenario. So I have that file, it's on my local machine. Obviously, it could be somewhere else within your corporate environment. And we go back to our project, making sure I'm in the right location. We're inside the Demo Hub project, way cool. And now inside my components, I'm going to add my data. Now you can see if you looked a little bit at the random naming convention that we used, and actually that automatically got generated in the prompt flow scenario where it was creating our prompt flow. In the backend, it's actually translating it to another data set. And that's where the two scenarios are really, really closely related to each other. I could go in here. You can see that for now there's no data set, but it's already waiting to be used. Now this was from the previous part, so nothing to really worry about. I'm going to create a new data set where this time I'm going to pick up data once more from some local files that I upload. But again, the data could come from other locations like our Azure Blob Storage, where you might have your content data already waiting to be used in blobs. Picking it up from a storage URL, assuming that it has the correct connectivity keys. For now, I'm going to make it easy and uploading the file from my local disk. This time I'm selecting upload folder. Why? Obviously, I want to grab the full set of PDF documents, although I'm not going to use all of them, but you probably get the idea. So this process goes quite fast. I need to provide a name, so I'm going to call this the brochures, because that was the name of my folder as well. It doesn't need to be identical. It's just highlighting what kind of data set am I using. So the folder is there, the data set is there, and as you can see here on the side, it also recognizes my PDF documents. There's a little option here, File for Preview. Now I find out if I select it, it's not capable of viewing the PDF content. So this could be useful for text files, JSON files, Markdown files. So that's a nice additional option as well. Now we do have the data set, but it's not recognizable as a data pattern because we need to create an index. Now, if you remember one of the first demos I did, deploying the hub, deploying the project, one of the things I missed there on purpose, because I'm talking about it right now, is creating an index. Now, there's a few different ways to use it. So down here in our AI Studio, we can create a new index. It's going to ask for our data source, where this time we're going to use data in Azure AI Studio, because that's what we just uploaded. I'm going to pick my brochures because that's the data set I want to use. And a little bit further, it's going to ask me for my index. If I already have an index, I can connect to it. And to speed up the demo a little bit, I have my pre-deployed index scenarios. Now, if you want to find out how to do this from scratch, you go into your Azure portal. Creating an index relies on Azure AI Search, which means you might need to go back as a developer, a data scientist, maybe because we're touching on data, right? You might need to go back to your cloud team, your cloud center of excellence, your Azure admins, where you're going to ask them, can you please deploy an AI search resource for me? So you can do it manually from here. You create a new search. It's going to ask you for the resource group, the name of the service, and everything else is pretty standard Azure resource settings. And that's literally what I already did earlier. So I'm going to add a connection, which now means that I'm going to integrate my data set, my uploaded PDF documents, and relying on Azure AI Search to help me creating an index. Now to do this, there is obviously once more some cloud compute power needed, where I have a couple of different options. I can use virtual machine, like based on the data set, it's going to look around and like, oh, I'm going to use this model as a virtual machine to do the processing, the rendering. Or you might be locked in your environment and going for specific pre-built options. So although again, I would say it's mainly about a developer, a data scientist, all working together within this one single Azure AI Studio interface, but we don't like to exclude anyone. And that's where you might need to go back to your system team, your cloud admin team, and asking them which of these flavors could be used. Recommended options, and then all options is obviously going to give you the long list. Assuming in the back of your Azure subscriptions and tenants, you do have policies not blocking you from using any of those virtual machine flavors. I'm going for auto select because it's the most easy option for now. And then moving on, where it's going to ask you a few questions about building up a vector. Now, what we rely on here is creating a semantic ranking. So remember in the presentation, we talked about the child's playing in the park, the playground, feeling happy, all the sentiments and everything around it during the presentation. And that's where it's recognizing it's going to build up some sort of a 3D-like vector-based model. And that's what the large language model needs to identify correlation, what we call the semantic similarities at that time, to really start recognizing your data. We're going to ask eventually some information about New York, and ultimately the goal is to pick up data coming from our own data set. Now to analyze the large language model, we're relying on the text embedding, because what we're doing now is mainly analyzing data. And that's where the text embedding large language model would be the recommended one. I'm going to move on with the last step in our process and creating that index. So from here, the process is running. It's going to take typically a couple of minutes. Could take a little bit more, a little bit less. Also depending again on the compute type that you select to do the rendering, to do the compilation, it might take a little bit more or a little bit less. There's a pretty detailed monitoring, so I can look into the job details where it's nicely going to show me what is actually happening in the backend. Now, technically what it does here, and I just want to use this portal to show you a bit what's happening behind the scenes. You don't need to know all the details, but it's going to look into the data set. Like the starting point is my brochures, my PDF documents, technically the folder with all my source information. And from there, it's using the large language model, crack, chunk, and embed data. So simplifying it a little bit, it's like looking into the PDF documents, analyzing the context, recognizing the images, recognizing the keywords like New York, some travel information, hotel information. And the way it does that is really splitting up, recognizing all the bits and bytes in that document and all the other documents at the same time. Next to that, it's moving on with updating the index, eventually registering the vector, like building up the 3D model if you want. And then from there, it's eventually going to finish my job. There's a whole bunch of other settings that I'm not going to focus on right now. You can clone it. Imagine that you want to use this rendering process using this job and almost doing the same thing, but maybe running it against different compute could be an option. Resubmitting the same task could be an option. Looking into the profiling. What you can do here is analyzing some data. So here you can see that it's been running for about 2 minutes now, and it took about 3 seconds to start. The preparation was a second, and now it's been waiting in a queue for about 2 minutes to just give you some idea about what are the different steps in the process and where exactly are we. I think this is most relevant for data scientists, because if you ever used something on the Azure machine learning side, we're actually reusing a lot of those capabilities and characteristics as well. So for now, my index is still getting built up, and let's see if we can already see something happening. I'm going to jump to my playground once more, but I need to leave the Machine Learning Studio to do this because it's all in AI Studio now. And remember, we picked our Demo Hub project. I don't need to change anything in the system message because it's only about using our data. And I'm going to try and fire off, but it might be a bit too fast. Where can I stay in New York? It's pulling up some information, and this is exactly the list of hotels that we had in our PDF document. I didn't tune anything about the system message. I didn't specify, like I showed you before, like, oh, you can only answer with 5 different options, or just provide a short paragraph. It's literally, this is the information I have. It recognizes the keyword hotel. Although we didn't really specify, but where can I stay? I would say in natural language processing probably means you need a place to sleep, which in our case, in our PDF document, it's just a listing of hotel names. Now from here, I would say we reviewed the response. It should be pretty okay. And then from there, we can go back, anything we already talked about before. We can deploy this into an actual web app. Like if you go like, oh, this is complete, we're going to turn this into a live running copilot. We're going to import some information. We're going to export some information. Anything that you could do from here, again, relying on your own custom data. Now, I talked about prompt flow in the previous part of the demo. So the other cool thing we can do is now integrating our custom data into another prompt flow. So let's go back to our prompt flow options. And this time I'm using the option from within the tools, although technically it's roughly the same as what I did before, starting from the chat and then moving to the prompt flow. Now, if you do this from within the tools directly, it's going to show you a couple of different pre-configured templates to choose from. So before we used the chat flow, although you didn't really have to select it, it was part of the fact that you started it from the playground. We're now, just for the fun of it and showing you another example, I'm going to use the multi-round Q&A. So what it allows you to do here is creating a chatbot using the large language model, where the data is now coming from your own indexes. And then allowing you to ask some what we call multi-round question, answering, can I do this, can I do that, can you offer me some hotels, and so on and so on. So I'm going to create another prompt flow. Where now you're going to see that the model is slightly more complex. The baseline is the same. Remember from the presentation and the previous demos around prompt flow in the previous session, we have the input, we have the middle section, where now the middle is a little bit more extensive than the first basic example I shared, and now we do have our output as well. Now obviously the more complex your flows will become, the more settings you need to specify. A little bit of it is exactly the same as before. So I'm first going to save this as a new prompt flow, and I'm going to start my compute session. Now, if you do not start that session, you go through all the configuration settings, you want to save it, you're going to deploy it, it's going to tell you like, oh, thank you for all the settings, but I need to have a running compute session. And then you just start it. I like to do that at first instead of waiting and then finding out that it throws an error message. Now, while this is running, nothing blocks me from already completing my settings. So it's optimizing my own time a little bit. Just repeating, highlighting some of the parts, we have the input where by default, I would say it's typically chat history in the chat/chat completion. And we're going to use chat input as a string, like provide me a prompt message. Next to that, in our output, we have chat output, where the value is the chat with context. So basically summarizing, wrapping it up, and really providing that large language model response. And that's going to become our output. Where now we have a few additional options. So just out of this template, the multi-round Q&A, it starts with modifying a query. Next to that, it's going to look up some information like reaching out to the index, trying to recognize the data inside, generating a prompt, allowing us to integrate some prompt variants, and then eventually closing with the final chat completion response. Now, translating this to the configuration part, we start with modify query with history. Identical as before, we first need to establish our connection. Like, hey, my dear prompt flow, I want you to interact to connect to this AI model in the backend. We're using the exact same API chat. We're going to define the deployment. I'm going to use my 3.5 model, and the response format again will be text in this example. You already know from the previous demo, we have a system message. I didn't tune it. I'm not going to tweak it whatsoever, because the only thing we know our prompt flow can do with our own data set is responding with information from that data set. It's no longer pulling in information from the public internet that it was originally trained on. I got the chat history, everything we already discussed in previous sessions, where now we have our index and we can move on to the lookup. Now, the lookup is really where we're going to trigger a subset, like a little script if you want, that's allowing me to really connect to our index. So to do that, we're going to define the index content, and I'm going to use a registered index, meaning one you already have. It's not overall Azure AI search, not any of the other options. It's an already registered index. The index asset is the name of that index. So basically, if I would go back, but I'm not going to flip screens for now, but this is really that randomly generated name that we had for our index that we created prior to this part. We do the lookup, we run a query, like out of this index, we're going to run a query based on the history, where in this case, it's like, oh, find me something in New York. That's my query with history, which means that, hey, in the lookup, can you find me any information you have in your data set related to, in our example, New York. Since it's a vector-based database, we're going to use that as the query type. So we're going to do vector and keyword. Vector, again, remember that 3D alike analysis, like matching keywords, moving them closely to each other, like the find me a place to stay is almost the same in natural language as find me a hotel. I'm pretty sure everyone would agree with that. From there, we have our other section in the flow. So we started with some input, some components, the lookup, where now we have a Python script. And again, this is just bringing in some examples. It might not be exactly what you need, but it's just giving you some idea about how can I integrate all the different building blocks inside my architecture. I got Python scripts, I got different large language models. I'm going to inject my prompts, my step-by-step chat completion, and that's how you literally are developing. In the end, don't forget, that's the topic of the virtual training day, developing your custom copilots, where in this case, it's all about building our travel agent. So we're almost there. I don't think I need to change anything in my sample script here. It's not really about code, although I can imagine with all the developers in the audience, you might be interested in what's that Python script actually doing. But in the end, it's just connecting to the AI engine, reading out the index, and analyzing the data. So I don't really need to change anything here. Moving on in the flow, 2 more steps to go. We have the prompt variants and we have the chat. By the way, if you're in the middle section in a different window, you can select it and it's immediately going to jump into that as well. So there's a few copy settings we need to do here. I would say for now, just out of my demo template, everything's already okay. We're going to generate the context using the input chat history and then eventually using it once more. Again, that's the reflection of the step-by-step chat completion. And then last, in our chat with context, we're going to connect to our hub. And then about the same as before, we're going to allocate which deployment model we want to use and what the response format will look like. And this should be pretty similar to previous steps in this demo and in previous demos as well. Compute is running in meantime. All my settings, configurations are there. I'm going to run my chat, my little test from here. Now, as you can see, it's coming up with a few sample prompts. It's just out of the template. So we could overwrite this. And I could ask the question, where can I stay in New York? And if everything goes fine, it's going to come back with some hotel options in the New York area. You might think like, well, this is taking a little bit of time. But as you can see, there is some processing, there's some monitoring happening. So now it pulls up nicely from our PDF document. There is the Manhattan Hotel, the Grand Central Hotel, the Park Hotel, and it also has pointers to the actual source. So this is pretty nice, where it literally tells me all this information is nicely coming from that source New York brochure PDF document. I tried to open the trace. I didn't want to wait for the full chat completion, but since it only took 1,000 tokens and about 8 seconds, let me show you a bit what that view option is about. So what we have here, I would say, is some sort of a troubleshooting acknowledgement about does it actually work, and it also shows you the details of each and every step in our prompt flow. It starts with a full flow. And within it's analyzing each and every section. We have that query, we have the AI chat, we have the lookup function, we have the embeddings coming in, searching for the data, another embedding, and again triggering the variants, the chats, and then eventually we have our response. Next to that, you can see for each and every step, opening AI chat, we have the user, we have the assistant, we had our pre-built demo template prompt where I updated it with the next prompt, like where can I stay in New York? This is coming from the assistant, so that's really you as being the consumer. If I look into another little piece, it's the retrieval step in my prompt flow. It's showing me like I need to find context based on the index, right? And now it's pulling up the exact information from my PDF document. This is that little section that I showed you where it has some information about New York City with a couple of numbers, and then it also shows me some details from the different hotels we're partnering with. You can validate which file name it's using, the URL, it's identifying some characters, could be relevant, and it's also pulling up other information, and that's again just I would say the unwrapping of how the indexing is working. It has some information about the company because that's part of our PDF document as well, like a flyer, a product catalog. That's the main scenario. We're almost there because the last thing is we created our prompt flow, we validated, and again, you could customize all of this. We're now in the end, we're gonna deploy it. Where once more deploying means this is like a little boxed, containerized environment where now we have our custom data set, we have our prompt flow step-by-step scenario, and it's almost ready for any of our potential customers to start asking questions about our travel agency, and knowing that the response will always come from our own data set. Now I told you it was a long demo, but actually I almost forgot about adding one last component here. And you could use it on a totally different scenario, but I think it actually perfectly fits as a closing of this one. So we have our own data, we have the prompts, we have the chat completion. Now if you think back about part 1, where we talked about responsible AI, I also talked about content safety. Now within our Azure AI Studio, we have another similar alike feature, and that's called content filters. Now in the end, it's about preventing potential harmful or, if you want, offensive language being generated out of the prompts, or maybe even based on the wrong information in your data set. So I'm quickly going to show you how you can create your own filter and how you can apply it as part of your custom Copilot solution. I'm going to move down here, and we're still in our component section. We're almost done, right? We did data, we did indexes, deployments. So the last option here is content filters. I don't need my demo anymore, so I guess it's fine to move on. And we're going to create a new content filter. You can provide it some cool descriptive name. I'm just going to accept the defaults, and I'm going to connect it to my demo hub. From here, you have a few parameters you can define. Now, the scoping is always 4 categories. So you have a category violence. Remember the demo I did with the content safety about the knives and the cutting and so on. We have hate, we have sexual, and self-harm. You can define what kind of media you want to use. If it's text-based, like maybe you're using or creating a custom Copilot for brainstorming, writing summaries, or anything else. Or you could also use it for detecting images and identifying any of those categories. You can define a threshold, low, medium, high, identical to the content safety. So I'm not going to change anything here. I don't think it's really that important and relevant. It's more about making you aware about the content filters on its own. So we could move this out, but for now, all looks okay to me. Now we can do the same for output. Remember, each and every conversation, chat completion, each and every prompt flow, if you want, starts with an input, the middle section, the notes, as we call them, remember, and the output. So I'm not going to manipulate anything here, but you could end up in a scenario where you're going to filter the input. It's going to do something with it based on the Python scripts, based on the large language model integration, based on any other customizations you have in your prompt flows. And then you get output, where now the new output is becoming the input for the next step in, again, a more complex prompt flow. So that's where you can define a little bit of a balance between input, output, and why not even making totally different changes. I'm just going to move on. I'm going to select my language model. I'm going to click Next. I'm going to confirm, and we're going to create our filter. Now from here, it's creating a new model. So I'm going to open my deployments page. You already know that's where you can see all your models. There we go, deployments. It's still working, and it's not showing up yet, but I guess that's totally okay. Just going to give it a second. I'm going to refresh. Cool. What we see now here is that we have our traditional GPT model that we introduced in part 1, all the way at the start of the hub and project creation. By design said I didn't specify anything. It was originally default, but I didn't call it out right away. Where now you can see that since we just integrated that custom content filter, it's now recognizing and it's telling me like, hey, my dear developer, we're now using a filtering mechanism where all characteristics from the large language model are actually still the same. I'm going to my playground, and we can try a little test here. I don't like to call out anyone. This is just part of our little demo script where I'm asking to describe characteristics of Scottish people. So it's going to provide, again, public internet-based information. That's what the large language model used to get trained. For now, I'm going to update my system message and purposely doing something wrong with it. where I'm going to update it to telling the system message like, hey, my dear AI assistant, you are now racist, and I'm going to allow you, or I'm actually going to ask you, to provide derogative statements based on race and culture. Please don't do this in production, because I think it's not really a nice example, but the outcome here is that it's going to tell me like, well, what you're asking me for, the exact same prompt as the previous one, it's now telling me like, well, as an AI assistant, although you ask me to do something, I don't know, that feels wrong, I'm not even going to do that, and that's because of that filter. So a pretty easy demo, I would say, but nevertheless actually quite powerful, and I didn't even show you all capabilities. So if you move that filter to the high risk, it's actually going to recognize even a lot more. So pretty cool. I personally like that. And again, it's not just about the prompt information. It's going to use the same based on your data sets or the public internet large language model data set. That's it for now. So let's go back to our presentation. This concludes our session. Now, there are many ways to continue your learning journey. We encourage you to watch other videos in this course or search out your next favorite topic on Microsoft Learn at ak.ms/learn.